My name's David Ware. I'm going to be talking to you about IBM MQ's Publish Subscribe features, specifically about using Publish Subscribe in an MQ network. So that's a connected set of MQ key managers. If you're not familiar with MQ's Publish Subscribe features, I have another session that's also on YouTube which goes into as an introduction about the various features of Publish Subscribe. So find a link below this presentation and that will take you to it. But for this session, what are we going to do? Well, we're going to look at the basic concepts of joining queue managers together to do Publish Subscribe. What are the various possible topologies that are available to you? Then we're going to compare and contrast them to see which ones suit which scenarios and what are the pros and cons for each of them. And then finally we're going to look at some actual scenarios just to put it into perspective. So, first off, we can consider doing Publish Subscribe on a single queue manager. In this situation, we have all the publishers connected to the queue manager and all the subscriptions defined on the same queue manager. In that instance, it's very simple for a queue manager to know where to deliver messages to. You publish a message, and using MQ's inbuilt topic tree structures, it can match it to subscriptions and deliver a copy of each message to each subscription. But in a distributed environment, where you have multiple queue managers, and some of your publishers are connected to some queue managers, and some of your subscriptions on other queue managers, you want to be able to publish on one queue manager and have MQ automatically work out where it needs to send the messages to where the subscriptions are connected, and deliver those messages to them in a reliable, efficient manner. You also want to be able to do that in a way that the applications don't need to know where the subscriptions are when they're publishing, and also, ideally, from an administration point of view, you don't want to have to fine-tune the configuration to specify exactly where all the subscriptions are. You want to leave that to MQ to sort out for you. So, what options are available to you? Well, there's a couple of main topologies. One is a hierarchy, where you join multiple queue managers together. Alternatively, you can use MQ clusters, where you federate queue managers so that they can become aware of other queue managers in the environment, automatically connect to them, and do Publish Subscribe across those. In both cases, you need to do some configuration to get these systems set up. So we'll start with configuration and then move on from there. So for a hierarchy, this is something that MQ has supported right from the very start when it provided Publish Subscribe many years ago. It's a way of manually defining connections between specific queue managers to say that they are related for Publish Subscribe. The actual configuration is very simple. All you have to do is go to each queue manager and say which is its parent queue manager, i.e. the queue manager above it in the hierarchy. So every queue manager here, you'd have to alter its parent value to the name of the queue manager above it, all apart from the queue manager right at the top, who obviously has no parent. These queue managers will then talk to its parent to communicate who they are and negotiate a conversation between them. To do that, they need to have channel connectivity. So you either have to have manually defined channels between these queue managers, or you could be within an MQ cluster and those queue managers can learn about each other. Because it has to do that communication asynchronously, once you've altered your queue manager to specify a parent, it's best to establish that the communication has succeeded. So to do that, if you do display pub sub on a queue manager, you can list all of its relationships. So if you do that on any of these queue managers, you should see who its parent queue manager is, and also if it has any children queue managers associated with it. You can also check your MQ error logs to make sure that the communication is successfully completed. Once you've got this set up, you'll see in a minute how publications can flow from any queue manager to any other queue manager in the hierarchy. And this is the default behavior. So as soon as you create a subscription on a queue manager within a hierarchy, any other queue manager where you publish will automatically send the messages to it. You can, if you want, scope down parts of your topic tree to say, actually, for these particular topic strings, I don't want to share my subscriptions or share my publications with other queue managers. and that's the subscription scope and publication scope, which you can modify on the topic objects within the topic tree. Once you have this set up, as you can see, messages will flow from the publishing queue managers, or the yellow one on the right, via its direct relationships through to the queue managers where the subscriptions exist. It doesn't flow directly from the publishing queue manager to the subscribing queue managers. It has to follow the route within the hierarchy definitions. So let's look at clusters. Again, clusters, we have to do a configuration step to establish the fact that you want to do publish subscribe between the queue managers. It's not just good enough for queue managers to be within the same MQ cluster to be able to do publish subscribe. Although, to start with, you don't have to worry about the channel connectivity like you do for a hierarchy, because any queue manager within a cluster can automatically learn about any other queue manager in the cluster, find out where it exists, create channels to it and send messages to it. So that side is covered. So instead, you have to do an additional step to make sure that when you publish on certain topics, they will flow through to the subscriptions on other queue managers. You do that by defining a topic object. You define a topic object, you associate it with the branch of your topic tree in your system that you want to be shared across all the queue managers in the cluster, and, just like for a clustered queue, you then specify a cluster name for that topic object. So here we define a topic object, we give it a name, fruitObj, we give it a topic string of price fruit, and then we associate it with cluster 1. By doing this, the queue manager which you define it on obviously is aware that that branch of a topic tree is clustered. Also, it will send that information up to the full repositories within your cluster, and they will then pass that information out to all the other members of the cluster. So now, as soon as you define it, every queue manager in the cluster becomes aware of the fruitObj definition and aware that it's clustered. So everybody in that cluster now immediately knows that any subscriptions that exist need to be known across the cluster, and any publications that need to be published might be being subscribed to elsewhere in that cluster. So that's the equivalent of joining the queue managers together in the hierarchy, apart from you're only doing it for a branch of the tree rather than the whole topic tree. We saw with the hierarchy, we send the messages via every direct relationship in the hierarchy. So we go up and down the tree. Clusters, we have two different routing mechanisms. We have the direct mechanism, which we've had since MQ version 7 and continue through version 8 and beyond. This is where, when you have publishers on some queue managers and subscribers elsewhere, the publishing queue managers create channels directly to the queue managers where the subscriptions are, and send the messages directly to them and onto the subscriptions. So that's the direct routing mechanism. In version 8, we introduced a new mechanism, which you can choose to use. You can still use the direct mechanism if you wish, but we have the topic host mechanism. The topic host mechanism, you control this by a new attribute on a topic object. So the object that you cluster, you can now set the CL route, whether it's direct or topic host. If you set it to topic host, where you define that topic object, which happens to be on the queue manager in the middle in this example, this is where we're going to route the messages via. So the publishing queue manager routes the message into the queue manager where you defined it, and from there that queue manager forwards it on to the queue managers where the subscriptions are. Now this is obviously a more indirect route, but it does have its benefits in some situations. So, which is best? Well, as you can probably guess, one size does not fit all. It really depends on many, many different factors within publish subscribe to actually decide on the best situation for you, the best solution for you. And to do that, I think you need to understand a little bit more about how it works under the covers so that you can understand what your system will be doing in the different environments. And from there, hopefully, we can make the right decision as to which solution to use for your topology. So, if we look at the mechanics, I've been talking up until this point about sending publications from queue managers to the queue managers where the subscriptions are. But how does MQ know that? It doesn't just send the publications out to every queue manager that it knows about in the hope that there are subscriptions there. It actually relies on a mechanism called subscription propagation. So when a subscription is created on a queue manager for a particular topic string, if that queue manager is in a hierarchy, or it's for a clustered topic, or at some point below in the topic tree where you've clustered, it knows that that information needs to go elsewhere in its topology. It needs to be sent to other queue managers, so that those queue managers know that this queue manager is interested now in those publications. So, first time it sees a subscription for a particular topic string, it builds a thing called a proxy subscription. It's really just a message which is going to send out to other queue managers. So it builds that proxy subscription message and sends it across MQ channels, point to point, to the other queue managers it needs to. The other queue managers depends on which topology we're looking at, and we'll look at that in a second. But for now we've just got the queue manager on the left. So we've sent that the proxy subscription information. That queue manager will create itself a subscription of a special type called a proxy subscription. And it's really just a subscription for a particular topic string, and it's pointing back to the queue manager where it came from. This will result in publications which match it being sent back to where the subscription actually exists. So if a publisher comes along and publishes a message, that queue manager will match it against any subscriptions it knows about. It'll match it to any of the local subscriptions and give them a copy of the message. It'll also match it to this proxy subscription, realise that it's being sent to a different queue manager, get the correct channel for that queue manager, and send a copy of the message to it. On arrival at the queue manager, which originated the proxy subscription, it will process it, again looking for any subscriptions it knows about. In this case, it knows about the local subscription, so it delivers that copy of the message to that local subscription. If you have multiple subscriptions for a particular topic string, it doesn't need to flow a second proxy subscription, because a proxy subscription is really just saying that that queue manager is interested in those publications, not why it's interested or who it's interested for. So here, now we can publish a message, one copy of the message will flow across the channels, and on arrival, 2 copies will be produced and delivered onto the 2 separate subscriptions. So this is the general mechanism that we're going to use for all the different topologies I've already talked about. And it really depends how you've wired the queue managers together as to how we send the proxy subscriptions, or where we send the proxy subscriptions. So if we look at a hierarchy, and we define ourselves a subscription down the bottom, we need to make sure that you can publish on any queue manager in this hierarchy and get a message back to it. And it has to flow following the connectivity of those queue managers in the hierarchy, so only via the direct relations. So when you create the subscription in a hierarchy, it'll generate a proxy subscription and it'll send it to the direct relations. In this case, it only had a parent on that bottom right-hand queue manager. When that queue manager receives it, it also generates a proxy subscription and sends it on to any of its direct relations that it hasn't already sent proxy information out to. So in this case, it's going to send it out to those queue managers, and then they're going to do the same and send it out to the other queue managers, until eventually the proxy subscription information is fed out to all the far reaches of this hierarchy. If a second subscription came along and another queue manager, it would do the same thing. It would generate a proxy subscription and send it out to the direct relations. Now when it arrives at the next queue manager, that one's already sent out proxy subscriptions to certain places in the hierarchy, so it only has to fill in the gaps. Right, so now we have 2 subscriptions in place, and we have proxy subscriptions that have flowed round the entire hierarchy, which means a publisher can come in on any queue manager and publish a message. Then, by publishing the message, we can follow the trail of proxy subscriptions all the way back to where the subscriptions exist, and then deliver the message to the actual subscriptions that actually need the messages. So that's how it works in a hierarchy. now in a cluster. Now this depends on which routing mechanism you're using. So if we first look at the direct mechanism, we're going to send proxy subscriptions from any queue manager where you create a subscription through to every other queue manager so that they know who needs the messages and how they need to connect to and send the messages back to. To do that, when you define your cluster topic object, that gets sent out to every queue manager in the cluster. As well as being told about the topic object, as we saw before, and knowing that now this branch of a topic tree is clustered, each queue manager has to become aware of every other queue manager in the cluster, because it needs to have the capability of being able to send proxy subscription out to anybody else that might need it. So when a subscription comes along on a queue manager, this time it's a queue manager on the left, it knows it's in a cluster. It knows that the subscription is to a topic string which is being clustered, so one below the clustered topic object. And at that point, it builds proxy subscriptions and it'll send it out to all the other members of the cluster. It does that by creating cluster sender channels to all those queue managers and then sending the proxy information across to them. Then another subscription comes along, it'll do exactly the same. So this is how we get the proxy subscription out to all the other queue managers in the cluster when you're doing direct routing. This means when a publisher comes along, over on the top right, when you publish, it has two proxy subscriptions on that local queue manager, each pointing directly to the two queue managers where the subscriptions have been defined. So that queue manager can again create cluster sender channels to those queue managers and send the messages directly to them and onto the subscriptions. So you get quite a flow of proxy information and quite a number of channels, but you get very direct flowing of publications. With the topic object, it's been drawn sort of floating between any queue managers. The reason being is when you're doing direct routing, it really doesn't matter which queue manager you define your topic object on. Because as we've seen, the information gets sent out to everybody and everybody acts exactly the same way, whether they've created the topic object or someone else created it in the cluster. So you just need to define it once, and you just need to pick a queue manager to define it on. If you're looking for a place to define it, then something like a full repository queue manager might be a suitable queue manager, because those queue managers tend to stay in the cluster for a long time, therefore there's no risk that the queue manager which you define it on drops out of the cluster, because if it does drop out of the cluster, then it'll lose the information that that topic has been clustered. So that's for direct routing. Let's look at topic host routing. In this situation, because we're going to be routing via the queue manager where you define the topic, we're not going to have to share the proxy subscription information as widely. So when we define our topic object, this time it becomes very important that you pick a specific queue manager to do it, because all the publications are going to go through this particular queue manager. So it needs to be able to handle the load, it needs to have good availability to make sure that it can be processing the messages continually. It also really needs to be able to separate from, say, a full repository queue managers. We always recommend full repository queue managers in a cluster, don't do application level traffic. So in this situation, you don't want to make a full repository the host of your topic, because that would mean all the application publications start flowing through full repository queue managers. Right. So what happens when we define that object? Well, we define the object as we did before, but this is a topic host routed one. The topic object itself still gets sent out to every queue manager in the cluster. But not every queue manager gets told about every other queue manager. It doesn't need to, because it's not going to contact them. Instead, each queue manager just gets told about the queue manager that hosted the particular topic object, all apart from the queue manager that actually hosts the topic object. This one is actually going to be told about everybody else. It needs to do that because there are some error situations where it may have to rebuild its information or confirm its information about other queue managers, in which case it needs to know about everybody. But when a subscription comes along, we're going to build a proxy subscription just as we did before. But instead of sending it out to everybody, creating channels and sending it to everybody, as we did in the direct case, for the topic host routing, all we have to do is send it to the queue manager where we've actually defined the topic, because that's where the messages are going to come from. Once it arrives on that queue manager, it doesn't go any further. It just stays on that single queue manager where you've defined the topic object. Similarly, we create a subscription down the bottom. It's going to do the same. It's going to create a channel and send the proxy subscription information. So this is good because we haven't sent much information about. We haven't had to create many channels. However, it does pose a problem. When a publisher comes along to another queue manager and publishes a message, it can publish it to a topic string under the clustered branch, and it knows it's being clustered, but it doesn't know about any proxy subscription information, so it doesn't know where to send the message to. So in that situation, all it does is take the message and always sends it on to the queue manager where the topic has been defined. So this is for a topic host rooted topic. So it creates itself a channel and sends the message on. When it arrives at that queue manager, a bit like it was in a hierarchy, when it arrives, it knows about the proxy subscriptions for the two queue managers where the subscriptions are, creates the channels and sends the messages on to those two queue managers. So we've ended up with the same end result. The messages have ended up at the two correct queue managers with the subscriptions. It's just gone via that queue manager in the middle where we defined the topic object. So let's do the side-by-side part. Let's compare these different solutions. Good parts and bad parts. So let's look at scaling. Hierarchies and topic hosts, clusters. These are quite good from a channel connectivity point of view because you've created this. You've defined exactly who talks to who. In the hierarchy, you know exactly who's talking to who. In the topic host routing, you know that everyone is going to connecting in only to that queue manager where the topic host is defined. So in a very large system where you have lots and lots of queue managers, you can scope down who needs to talk to who, or in a system where you need to control the connectivity. Direct clusters, on the other hand, that can be a concern. If it's a particularly large cluster, with hundreds, possibly even thousands of plus queue managers in it, then a direct cluster means the channels will connect between all the different queue managers. Probably unnecessarily, because you're probably not publishing or subscribing on all of those queue managers. Another aspect of scaling can be considered the frequency that you create and delete subscriptions. If you're continually creating and deleting subscriptions, we have to flow the proxy subscription around. With hierarchies and direct clusters, that proxy subscription information flows to all the different queue managers eventually in the system. Whereas on the topic host cluster routing, it just sends it into the queue manager where you've defined the topic host. So that's another aspect of scaling that can be considered. What about the publication flows themselves? Well, if you look at the direct cluster, that's a nice efficient mechanism because there's at most one hop between the publishers and the subscribers. Obviously putting the publishers and the subscribers on the same queue manager is even better, but at the very least you are only one channel hop away from a publishing queue manager to a subscribing queue manager. So that's nice and direct, as you'd expect. For hierarchies and topic host clusters, you've got potentially multiple hops. A hierarchy, however you define it, that's going to dictate the maximum number of hops. A topic host cluster, that's going to be 1 or 2 hops, the 2 hops being the maximum. But in both those situations, if performance and latency is important to you, you can carefully architect your solution to make sure that you minimize those hops. So if we look at, say, the topic host cluster, we could realize that the publishing queue manager is where all the messages are coming from, and instead of defining the topic host on that queue manager in the middle, you could remove it from there and define it on the actual queue manager with the publisher. Now in that situation, you benefit from the proxy subscription information just being sent up to that queue manager, and the fact that you're now back to at most one hop between the publishing and the subscribing queue managers. You could do the same with a hierarchy if you were to say put the publishing queue manager as the root of the hierarchy. So what about configuration? Well, this really comes down to what's your particular style, what do you like? Hierarchies, they need a lot of planning, they're quite static, they're quite hard to alter. you can add queue managers too, but if you want to remove queue managers or remodel the hierarchy shape, then you have to sort of tear it down and build it up again. So that can be quite a lot of work. Clusters are a bit more dynamic. Obviously you can add and remove queue managers into a cluster dynamically, and if you do that, they'll automatically learn about the clustered topics, and they'll learn about any proxy subscription information that they need to. Direct clusters are obviously simplest because you can just put your clustered topic anywhere you want and everybody is just going to go direct from publishers to subscribers. Topic host cluster routing, that requires a little bit more thought because you've got to carefully plan where you're going to put those topic definitions. Availability. Now, if we look at each one of these, what happens if we lose a queue manager, if a queue manager becomes unavailable for whatever reason, whether it's planned or unplanned? In a hierarchy, if you take a queue manager out that's in the middle, you're going to potentially be cutting publishers off from the subscribers, and you're not going to have any other way of getting those messages through to those subscribers until you bring that queue manager up again. There's no alternative mechanism. A direct cluster, if you take a queue manager out, obviously that queue manager is no longer going to be working, so if that's got publishers or subscribers on it, you're going to have a potential problem. But any other queue managers, they're not going to be affected at all because they're just going direct from the publishers to the subscribers. So availability isn't such a big concern there. Topic host routing, you're back to a similar situation as you are with a hierarchy, in that a particular queue manager now is very important to the flow of publications. So if you take the queue manager out, which is the topic host, then you're going to stop publications getting through from publishers all the way to subscribers. So that is a similar issue to hierarchies. However, we can avoid that for the topic host routing. Because unlike with a hierarchy, where you can only have one possible route in the hierarchy between queue managers, for topic host routing, we can do a similar thing to we do with queues. For a queue in a cluster, you can define it on multiple queue managers, the same name, the same configuration, and we will workload balance messages across those multiple instances, and we will route it to the available instances of a queue manager. And as you might have imagined, you can do the same for topics. So if we define that topic host routed topic definition now on two different queue managers, the same configuration, the same topic object name, the same topic string, now, rather than just one of them learning about the proxy information, both of them will be told about all the proxy information within the cluster. So it's increased the proxy flow, it's increased the connectivity slightly, but it does mean now that we could send a publication to either one of those two queue managers and equally be able to process the message and forward it on to where the subscriptions are. So that's exactly what we do. When we publish messages and we've got topic host definitions, if there's more than one of them, we will workload balance the messages across them. When it arrives at each of them, then the queue manager which it arrives at will send it out to all the subscriptions. So message 1 goes to topic host A, message 2 goes to topic host B, and so on. And this allows you to increase both the scalability, so we've now got two routes for any of the messages. So each individual queue manager is actually doing half the load of the system rather than the full load of the system, which it was with a single definition. So we can now horizontally scale out publications as we increase the load. Also, the availability problem. If we take out one of those queue managers, whether it's planned or unplanned, the publishing queue manager will recognize that that queue manager isn't available, and it will send all future messages via the remaining queue managers, in this case, that top queue manager. So messages will still flow through to the final subscriptions. The downside of this particular approach is you'll no longer maintain the relative order of those publications. Because we're workload balancing messages across multiple different routes, there's no guarantee that they're going to arrive in the same order that they're published in. If that's a problem, then you can at least take some steps to increase your scalability, your scalability by defining different topic objects for different branches of the topic tree on different queue managers. If you do that, and we've got, say, all the fruit publications going via one of the queue managers and all the vegetable publications going via a different queue manager, you're again separating out the load of the publications across multiple different queue managers and different channels. So that will at least reduce the load on any one single point in your cluster. So let's look at a few scenarios just to make it clear exactly where the pros and the cons come into any solution. So this is a big hub and spoke cluster design. This is a common pattern where you have many queue managers, which you might have 1,000 or more queue managers, which are small queue managers, maybe distributed around the globe, maybe in the back room of a superstore or in a bank or something like that. And then you've got headquarters, where the headquarters can handle talking to everybody, but everybody else can't handle talking to the individual other queue managers in the system. And they never need to. They never communicate directly with those queue managers. Now, if you want to do publish subscribe in a cluster such as that, if you were to use a direct clustered topic and define that, as soon as you create a subscription on any queue manager, it's going to communicate with all the other queue managers in the cluster. And suddenly you're going to have channels being created between all of your spoke queue managers around the edge, which isn't a situation that it's been architected for. So you don't want to use a direct cluster in this situation. Instead, what you probably want to do is you want to use topic host routing. You want to, in this situation, we brought in a new bank of queue managers, let's call them the gateway queue managers, and that's where we're going to be routing all of our publications and all of our subscription traffic through. So whenever a subscription gets defined, it gets sent into those 3 new queue managers in the middle. And whenever a publication gets sent out, it'll always get sent to one of those 3 queue managers, and then from there on to where the subscriptions are. So the connectivity model goes back very much to a hub and spoke style pattern. If we look at another situation, it's not as architected as the hub and spoke pattern, but it could be just as big. Say you've got a cluster which has got hundreds or 1,000 queue managers within it, and it's grown up into this over a period of time, but it's not really one big system where everybody is talking to everybody else. Instead, it could be a collection of many different applications spread across a handful each of the different queue managers in the cluster. So it's really just a cluster for simplifying administration rather than using it for connectivity. Now in the point-to-point world, that works quite nicely because those queue managers will only communicate with the ones that they need to talk to. So only communicate to the queue managers which host the queues that they're actually using, never to everybody in that cluster. But if one of those applications, using say the 3 queue managers on the right, wanted to start using publish subscribe, we would be back to the same problem we saw a minute ago, which was if you use a direct cluster, the queue managers where you define your subscriptions on are now going to start talking to everybody else. They're going to start knowing about everybody, they're going to start sending that information out to everybody else in the cluster, which again is possibly not a good thing for this particular setup. It's not how you scaled it, how you designed it originally. So what's the alternative? Well, there's a number of alternatives here. Possibly the nicest solution is to create yourself a new small cluster. Define just the queue managers which need to do publish subscribe within that cluster. You don't have to create new queue managers. You're just creating a new cluster and making the existing queue managers that need to a member of that new cluster as well as their existing cluster. Once you have that new cluster in place, define your topic definition, maybe as a direct routed topic, on a queue manager within that cluster and specify that small cluster name rather than the big cluster name. That way, all the subscription traffic and all the publication traffic is going to be restricted to just the queue managers that are members of the small cluster. It's worth mentioning at this point that if you're in a situation where you don't want to have the possibility that queue managers can define themselves a clustered topic and possibly cause all this interaction to happen where you don't want it, you can disable clustered pub sub on queue managers. You can say ps-clus, which is a queue manager attribute, and set it to disabled. It doesn't work by saying, well, I'm going to pick some queue managers to disable it on and others that I won't. what you actually need to do is you really need to set it on the full repository queue managers in your cluster. If you set it in your full repository queue managers in the cluster, that will prevent any clustered topic definition that they become aware of on a queue manager that might have accidentally defined it from being sent out to all the other queue managers in the cluster. So in this picture, you would set it at least on the full repository queue managers for the big cluster and not the full repository queue managers for the little cluster. What other solutions could you use? Well, you could use a hierarchy because it's only a small network of queue managers. Just because you're in a cluster doesn't mean you have to use clustered pub sub by defining a clustered topic object. Instead, you could just define hierarchy and have the connectivity using that model. And again, in that situation, you could set PS cluster disabled for all queue managers because none of them are actually going to be defining clustered topics here. Or you could, if you wanted, use topic host routing within this system. By doing that and setting it on a particular queue manager, you're not risking every queue manager that creates a subscription from communicating with every other queue manager in the cluster. So you don't have that particular problem. However, it is possible that the queue manager where you define the topic object that might need to talk to everybody. I said earlier on that in some situations a queue manager that's a topic host might have to communicate with the rest of the cluster just to reset its knowledge. Also, it means you're defining that topic object within the cluster, the large cluster, therefore you have to have PS class enabled everywhere. We've gone through hierarchies and cluster configurations. Now let's look at a couple of specific scenarios. First, a very dynamic setup. If we have lots and lots of subscriptions coming and going very frequently, it could be many a second, all on lots of different topic strings. It could be a very dynamic topic string structure. When this is happening, and you're doing it across a set of queue managers, we happen to have 3 here in the middle, maybe for availability or for loading the subscriptions across them. If you do this, then it presents a specific problem. This is the fact that for those queue managers to flow the proxy subscription around, to keep each other up to date with who's subscribing to what and on what queue manager, you might impose just as much load into the system for proxy subscriptions as the publication traffic itself. And that can cause problems. It might overload the channels. It also might slow down to a point where the proxy subscriptions are being flowed at the wrong point compared to when the subscriptions exist. So the queue managers effectively get behind in processing the proxy subscriptions, and therefore the publications don't flow correctly. So what can you do about this situation? You can switch from the subscription propagation model, which we talked about earlier when we talked about flowing proxy subscriptions around, to a publication broadcast model. Now, publication broadcast means we're going to send the publications out to every queue manager just on the off chance that they have a subscription matching it. If they don't, then we've just wasted a trip of that publication, but other than that, no harm done. So how do you do it? You do it by setting a particular attribute on a topic. It's called proxy sub. So it's the proxy subscription attribute. The default is first use, which is the flowing proxy subscriptions around when you first use a particular topic string. So that's what we've talked about up until this point. But here, if we set it to force, that means at the time you configure the object, that's when we're going to send a proxy subscription out. And we're actually going to send it out with a hash wildcard on the end of the topic string that the topic represents. So here we've got a topic that's defined for the /orders node in the topic tree. If you set proxy sub to force, put it in the cluster, then we're going to send proxy subscriptions out from every queue manager to every other queue manager of /orders/hash. So bear in mind that it's not just where you define the object in a cluster, it's on every queue manager in that cluster. So as soon as you've done that, we've now got these wildcarded proxy subscriptions in place, which means with the subscriptions, we don't have to send out the individual proxy subscriptions for each individual topic string underneath the /orders branch of the topic tree. Because when a publication comes in, we're always going to have the 2 proxy subscriptions that match it, the wildcarded ones that point to our 2 other queue managers here. So we're always going to send 2 copies of the message out at that point. And then from there, we're always going to send the messages on to any subscriptions that happen to exist that match that particular topic. So we don't have to send the individual subscriptions out. It's worth pointing out that in version 8 we improved on this, in that we cleaned up the mechanism for not sending out the additional proxy subscriptions. There's more information in the notes. Subscription availability. This is a specific scenario which isn't really about moving publications around the system to match subscriptions. It's more about how do you make a subscription itself, a single subscription, highly available, or at least continuously available. We have this problem in point-to-point, where we're sending messages from an application on one queue manager to an application to a queue being processed by another application on another queue manager. When we send those messages, we send it in the cluster, say, via the transmission queue onto the queue manager where the queue exists. However, if we were to have an outage on that queue manager, those messages would simply build up. So many solutions involve, instead of having a single queue manager where you define the queue in the cluster, you have multiple queue managers. You define the same queue on both those queue managers. You deploy your application to both of those queue managers to consume those messages, and now we're going to workload balance the messages across them, and we're going to route around failures. So if we lose a queue manager, all the messages are going to get routed via the remaining available queue manager. So this keeps your application continuously available for processing new messages. So that's the point-to-point, but really that application, that pink application down the bottom, that could just as easily be a subscribing application in a publish-subscribe world. So how do you get the same behavior in publish-subscribe? Many assume that the simple way to do that is we're in a cluster, so we cluster the topic and we create the subscription, the same subscription on 2 different queue managers. If we do that, you expect to get the same behavior that you got for queues. In fact, what you get instead is those 2 subscriptions are seen as 2 very different subscriptions, and whenever you publish, each message gets duplicated and sent out to each of those matching subscriptions and processed. So you've now got 2 sets of each message being processed, whereas actually what you wanted was 1 copy of the message being processed by either one of those 2 queue managers. Excuse me. So that's not the solution you want to use here. Instead, you really want to drop back to local publish subscribe and point-to-point within the cluster. So the first thing is you don't define the topic as a clustered topic, which is the obvious thing that you may consider doing. Instead, you're not doing publish subscribe on those bottom 2 queue managers. You're doing exactly the same as you did for point-to-point, where you're using 2 copies of a clustered queue to achieve workload balancing and routing around failures. And your applications, rather than being subscribing applications, are going to be point-to-point consuming applications directly from the queue. Now, we need to set up a subscription so that it matches messages being published on a particular topic. So that's where we define it on the queue manager where the publisher is. We don't define it down where the applications consuming the messages are. And instead of defining a subscription for a queue down a simple queue associated with a subscription, what we do is we define the subscription on the top queue manager, but we specify the cluster queue that we've defined the same on the 2 queue managers down the bottom. We don't specify a target queue manager on that subscription. We leave that for the cluster resolution logic to work out where to send the messages to, and that's how we're going to achieve workload balancing and routing around the failures. Because when we publish a message, we match it to the local subscription, which matches it to the queue that's associated with it, which happens to be the clustered queue. Being a clustered queue, it will resolve it to those 2 bottom queue managers, decide which one to send it to, and send the message on. Workload balancing and routing around the failures. One downside of this solution is, if you've got publishers that can come in on multiple different queue managers, because it's only a local subscription and we're not relying on clustered pub sub, you have to define the subscription on each of those queue managers where the publisher is, so they can each resolve down to where the subscription queues are. Finally, a few hints and tips on when you're setting up such a system. Because when you set it up and you're going through those early stages, it's quite easy to introduce problems or not know what's going on. Hopefully this presentation has helped you understand a little bit more about what you should expect to go on behind the scenes. The problem determination helps you to diagnose where it hasn't worked correctly. First thing to check, always double check your configuration. Check what you've defined, check your topic definitions, check your hierarchy relationships, check your cluster configuration. If you're in a cluster, check each queue manager's knowledge of the cluster. So this means you can go to any queue manager in a cluster and display the cluster queue managers that it knows about. If you've defined yourself a direct clustered topic, every queue manager should know about everybody else. So check that they do. If they don't, then something's probably gone wrong. And if you have defined a clustered topic, check that it also is known by every queue manager in the cluster as well. So you can do display t-cluster, for example, on a queue manager using run MQSC, and that will display the clustered topics that it's been told about from the full repositories. So that information should have been sent to every queue manager. In version 8, we've also added a new attribute to a clustered topic object called cluster state. This gives you some more information about possibly what's gone wrong. It'll tell you that the information has been successfully sent up to the full repositories and sent out to the other queue managers, or that an error has occurred. If you're in a hierarchy, check the relationships like we saw at the start. Use display pub sub, and that will show you who your parent and who your children are. Always check the error logs. In MQ, we'll write to each queue manager's error logs whenever we see a problem. So if we see a problem setting up a hierarchy, or we see a problem sending messages around the cluster, then we should be writing messages into the error log telling you this. Check your channels. All of this relies on being able to successfully send messages between two queue managers, which means we have to have working channels between them. So make sure the channels are running, make sure there aren't any errors on the channels to prevent you sending those messages. Also, check your proxy subscriptions. So we've talked about proxy subscriptions. You should understand where they should exist and where they shouldn't exist. You should be able to go in and check them. You can go in and do display, subscription, subtype proxy, and that will show you all the proxy subscriptions that a queue manager knows about. So I recommend you do that even on a running system, so that you become aware of what they look like and where you expect to find them. Check your topic status. Your topic status is showing you what the topic tree looks like. From here, you'll be able to see the resolved attributes for each node in the topic tree, and you might be able to spot an inconsistency in your configuration. Perhaps where you've defined something like clustering at one level, but you've scoped your publications down at another level, and that's actually preventing publications flowing between queue managers. Watch out for moving of messages between the queue managers. So it can be hard to work out exactly how far the messages have flowed, whether it's got off of the first queue manager onto the second one, or from there onto the next one. So have a look at the status of your channels, look at where messages have flowed, where messages might be built up. So on that note, look at your transmission queues. Look out for any queues in your system where you're not expecting messages to be built up. In the notes of these slides, which you can download from SlideShare, you'll find details of the various system queues and which ones shouldn't have any messages built up on it in a healthy state. And that brings me to the end. So we've covered the basic topologies, we've looked at what you can configure, we've compared and contrasted them, and then we finally looked at the various scenarios which you have to apply them to. So hopefully that gives you a good background into knowing how to set up an MQ topology with Publish Subscribe. So thank you very much.